Hi there. In our last section, you learned how to define a linear programming. You also learned the different terminologies related to the linear programming. In this section, you are going to learn how to solve a linear programming problem. So let's begin. Linear programming problem. Let's consider an example of a linear programming. So here's the example. Solve linear programming graphically. Maximize z is equal to 4x plus 5y subject to constraint 2x plus y is less than or equal to 8, x plus y is less than or equal to 6, x is greater than or equal to 0, and y is greater than or equal to 0. As you can see, this is my graph, this is my x-axis, and this is my y-axis. This point here is the origin. Now what I want to do, I want to first graph the first inequality. So if we graph the first inequality, this will be the graph of my first inequality. Now let's graph the second inequality. So this is the graph of second inequality. I'm not going to discuss how to graph it because it's not like you guys don't know that. Like we already have done the graphing in a lower grade level, so I don't want to spend time on graphing. I'm assuming that you already know the graph. Let's try to understand what it simply means. So technically, 2x plus y is less than or equal to is this equation, and x plus y is less than or equal to 6 is this equation. So basically, like these two inequalities are basically this area. So if we look closely on all these four constraints, we are considering basically this part of the inequality. So let's consider the point of intersection. So the point of intersection of these two lines is this point, which is 2, 4. This point that we need to find is 4, 0, and this point is 0, 6. Now let's create a table to find the values at these 3 points. So if we consider a table, this is my table, these are my corner points, and z is equal to 4x plus 5y, which is from here. When x is 0, y is 6, let's substitute the value over here on this expression. Then we'll get 4 times 0 plus 5 times 6. 4 times 0 is 0, 5 times 6 is 30, 0 plus 30 is 30. Now 2, 4, x is 2, y is 4, so 4 times 2 plus 5 times 4, 4 times 2 is 8, and 5 times 4 is 20, so 8 plus 20 is 28. 4, 0, so 4 times 4 is 16, and 5 times 0 is 0, so 16 plus 0 is 16. As you can see, the value at point 0, 6 is 30, 2, 4 is 28, and 4, 0 is 16. And out of these three values, the maximum value is 30. So this is my maximum value. In other words, we can say that the linear programming has a maximum value which is 30 at point 0, 6.